Hello dear students, today I will discuss about difference operators, relation between operators, and just in the previous class we have already discussed about forward del operator, backward del operator, central del operator. Okay, now just definition we know, because the difference there are also two operators or more operators, and there is some questions involving these operators. We can solve questions by using the definition of this difference operator and also relation between these operators. Just today I will establish the relation between these operators, and also operators can be used for finding differences. So here just see the definition. What was the definition of these differences? As what? Y x plus h minus yx. Here y x minus yx minus h. Here y x plus half h minus yx minus half h. This was the definition, okay, of forward difference, backward difference, central difference. Okay, so there are some questions also may be asked in the exam, just like question. Suppose evaluate the difference, just like this, difference of 10x. Okay, there are some questions, tan inverse x, e to the power x log 2x, and etc. Function may be what, because this is what yx means function of x. That is here maybe tan inverse x. This is function. Okay, so first order forward difference, just find this difference. So this difference, this is function in place of what? Fx. In place of fx, tan inverse x. Okay, it's difference, first order difference. How can we find this difference? Using this definition in place of yx, that is what? We also know fx means fx plus h minus fx. Just use it. Interval of differencing is h, because at the arguments, the values of x are at equal intervals. Suppose at the interval of h, so this is equals to, this will be equals to what? First, this is fx. So tan inverse x plus h minus tan inverse x. Now it can be solved and can be expanded. That will be the difference. Okay. So here tan inverse x plus h in place of x plus h, and minus x, tan inverse a minus tan inverse b. So we know that tan inverse a minus tan inverse b means what? X plus h minus x upon 1 plus x plus h into x. This is equals to what? Tan inverse x cancel, h upon 1 plus x plus h. This is the first forward difference of tan inverse x. So there may be different type of functions, and it may be asked to find the first order difference, second order difference, third order difference. Okay, so this type of difference we can find. Here e to the power x log 2x also given. Suppose maybe asked the questions as find the difference, forward difference of Here e to the power x log x. And second question, e to the power x log 2x. Also second difference, just like first difference. E to the power x log 2x. Just like this, e to the power x log 2x. This is a function of fx. So first order difference finding means what? Just use this definition. So this can be written as first of all, first value of the function in place of x we have to write x plus h, where h is the interval of differencing. H is interval of differencing. So here e to the power x plus h log of 2 x plus h. This is first value fx plus h, yx plus h minus yx, that is this e to the power x log 2x. Clear? This is first difference. Now it can be simplified. It can be simplified and you can write the answer. How? E to the power x into e to the power h log 2x plus h minus e to the power x log 2x. So e to the power x this question can be simplified in terms of log series. We can write it, just take it with together, okay. Just difference means this. Now just only setting is here, okay. X plus h, this e to the power x plus h log of 2 times of x plus h minus e to the power x plus h log of 2x plus e to the power x plus h log of 2x. This minus e to the power x log of 2x. Just we add and subtract this, because 2 times of this, to log 2x log 2 e to the power x plus h e to the power x minus h minus and plus. Just we have to write like this, plus and minus, just add for adjusting, okay. And this is equals to what? For finding difference, just finding difference means what? Just del of this, apply the definition and then just simplify it. You can simplify here e to the x plus h, e to the x plus h. So this is equals to also what? Log 2x is equals to, this is equals to, after this line, e to the power x plus h, and common is this, now log of this minus log of this. So what? Log of 2x plus h upon 2x. We can write now. What? Log a minus log b, e to the x plus h is common. Log a minus log b means log a by b. So log a by b, and here plus this e to the x into e to the h, e to the x is common. From here we can take it common as what? E to the power plus e to the power here x log 2x common e to the power h minus 1, e to the power h minus 1, because e to the power h minus 1 e to the power x log x common. So express it in a simple way. So log of what? X divide 1 plus h by x plus e to the power h minus 1 log of 2x and e to the power x also. Okay. So this is answer. This is answer. Just you have to write in simple way. In a simple way. Okay. You can write in a simple way of this. This is the difference. Okay. This type of questions, there are many questions. So just practice by using definition. Okay. So here one of the questions is also here. just try to find the value of del n e to the power x. Del n e to the power x. Find the nth derivative of e to the power x. And derivative, not difference. Okay, just find nth difference. Clear? So try to find the nth difference. We know nth derivative is what? E to the power x. Here difference. Just we are trying to find the difference. Okay. So for that, what will be the process? Del n. So del e to the power x equals to, first time, e to the power x plus h minus e to the power x. So here we can take common what? E to the power x and e to the power h minus 1. So constant term is what? E to the power h minus 1, 1 times e to the power x. So we see that what? 1 time, then e to the power h minus 1 comes 1 times. Okay, these are the constant. And also remember that the operator just distribute linearly. Okay, and constants can be taken outside of the difference. This first difference. Also second difference, just del square del e to the power x. Del square means second derivative. Difference. Second difference will be what? Del e to the power x. Okay, so del e to the power x is this, e to the power h minus 1 into e to the power x. This is, but we know this is constant term because not related to x, so it can be taken outside. So del e to the power x, it will give e to the power h minus 1 square, because this is equals to this again. So square e to the power x. So del 2 e to the power x equals to this 2 times. Similarly, we can get nth time when take difference, then we can get e to the power h minus 1 to the power n e to the power x. So nth difference is this. Okay, nth difference is this. Clear? Just in this way you can find the difference of function. Okay. Now a new topic is discussion with you, that is factorial notation. Just here we see that the one thing, note down this, there is a factorial notation. Factorial notation is important for difference calculus, because for factorial notation del work as a differential operator, just like del x square, we can find x plus h square minus x square. Okay, but if this x square is taken as a factorial form, then this del work as differentiation 2 of this. This is known factorial notation. Now note down, factorial notation is what? Factorial notation is denoted by this product of r quantities. This is factorial. R factorial means just start from where? X. Okay. First x, then x minus h, then x minus 2h, then up to x minus r minus 1h. This is r terms, product of this quantity. First that quantity and decrease by H, interval of differencing. This product is denoted by this x r factorial. This is the factorial notation. Every polynomial of nth degree can be expressed as a factorial polynomial of nth degree. Means in place of x we can write factorial notation. But for that coefficient will be changed. Just like this. Suppose here we see that if h equals to 1, then this is equals to what? X. 1 r, then r minus 1 time is subtracted. 1 then 1 minus 1 time means 0 times subtracted means x. Okay, and x2 means r minus 1 time is subtracted. Here 2 means, so 2 minus 1 time is subtracted means x minus 1h, but h equals to 1. So this here 2 minus 1 time subtracted means 2 minus 1 equal to 1 time subtracted. X minus 1 h equals to 1. Similarly, we can write third what? X minus 1, x minus 2. This is factorial notation, and this is equals to this symbol. Okay, so this is equals to this x square minus x square minus x. This is just after multiplying you can get cubic polynomial. Okay, so here just note down that what if we write a polynomial, simple polynomial of nth degree in factorial notation. Every simple polynomial of nth degree can be expressed as a factorial polynomial of nth degree. For that we have to do some process. There are 2-3 techniques. Just remember that every polynomial, every simple polynomial of degree nth degree can be expressed as a nth degree polynomial, factorial polynomial. For that we can use a process. Here just take a question first of all. Okay, so take express y equals to 2x cube minus 3x square. The given question, express y's function is equals to 2x cube minus 3x square plus 3x minus 3x square plus 3x minus 10 in a factorial notation, and hence show that del q y equals to 12, and hence so that del q y equals to 12. That is, we are given solution. We are given this simple polynomial. This polynomial, because every polynomial of nth degree can be expressed as a factorial notation of same degree of polynomial. Factorial polynomial of same degree. So here, this is simple polynomial. If suppose there is some term are missing, just like here x power 1, 2, 3, all terms are there. If this was missing, then just write first of all the first method, that is very very important method. Since we know that every polynomial of nth degree can be expressed as a factorial polynomial. So let y equals to a x cube in factorial notation, b x c d. That is third degree polynomial in factorial notation. We know because given polynomial is a simple polynomial 3 degree. So it can be expressed as a factorial polynomial of same degree. So just coefficients are suppose a, b, c, d. And this is factorial polynomial. Just now we have to find a, b, c, d. By a method we can do it. Okay. Finally we have to solve this. Find this. Okay. Prove this. Now here for finding a, b, c, d, there is a method. Just write first of all given polynomial as a descending powers of x. Here also write it as a descending power of x. Maybe they are polynomial just like this, x minus 2x square plus 6x cube plus 2. Maybe this is a polynomial. Because descending order means power of x. First of all 6x cube minus 2x square plus x plus 2. This is descending order. This is the order. Okay, so just write like in descending order and then take coefficients. Now our process is let this then just like here coefficient of x cube, x square, ax and constant term. Coefficient of x cube is what? 2. X square minus 3. X 3 and d minus 10. These are the coefficient, constant term. Okay? This is constant term. Okay? And finally we have to, this is part of question, na? We have to prove this finally. So just write coefficient and one line is here. Okay? Now 1 by 1, 1, 2, 3 and so on, we have to divide. Division is just like that because first coefficient remains unchanged. So here we take 2 as it is. 2 as it is carry. And then 1 into 2, just like synthetic division. 1 into 2, 2. We get, now add this 2. 1 into 2, carry over this 2. And 1 into 2, 2. And minus 3, 2. Add this 2, minus 1. Okay, now 1 into minus 1, here minus 1. Now add this to 2. So here, this is d. Constant term is always remain unchanged. So here, like this. This is d. And this value is c. Okay. Take carry over this. Now 2 into 2, 4. This. Add this 2. 3. This is b. Here this is a. Just carry over this. This is a, this is b, this is c, this is d. 2, 3, 2 minus 10. Okay. 2, 3, 2 minus 10. Clear? Process is what? First of all, write 4-degree polynomial, 5-degree polynomial, any polynomial. First of all, write the polynomial as a descending power of x. If there is some term missing, then just supply 0 as coefficient. Suppose x term is missing, then just write 0 into x, and 0 will be here. Clear? Suppose x square term is missing, then 0 into x square, and 0 will be here. So just write descending power of polynomial as a descending power of x. Then write its coefficient. Last term, constant term will be d. Just suppose third, cubic, fourth, fifth, one term is constant term, so that will be the constant term. Now, write 1, 2, 3 and so on, and carry over to its coefficient, first coefficient, that will be remain unchanged. So 2 is here, 1 into 2, put here, then sum it, minus 1, and 1 into minus 1, put here, that is minus 1, minus 1 and 3, 2. So D, and this is C. Now take in this portion. 2 carry over, 2 into 2, 4, put here, sum it, 3, this is B. C, D, C, B, and just one term remaining, 2 carry over, 2 in A. So A, B, C, D are this. Therefore, y is equals to A, 2, B equals to 3, C equals to 2, D equals to minus 10. So this polynomial can be written like this in factorial notation. Clear? Since in factorial notation del is equivalent to derivative, differential operator. Therefore del y is equals to del of this, del of 2x cube 3x square 2x minus 10. Okay, now we can find it. First difference. Okay, this was the method. Now for finding del q y, we can just 3 times differentiate it. You can solve it. Very simple. Okay. So first time differentiate, just differentiate it, because in factorial notation del is equivalent to d, differentiation operator. So just differentiate it. What? 6 del y equals to 6 to this x cube means 3x square means 6 this. Now here 6x plus 6x, and here 2 minus 10 0. Differentiation, just do differentiation. Okay, implies del square y equals to del of del y. So del of 6x, just differentiate it. Differentiate it means what? 12x plus 6. This is second difference. Therefore, cubic difference, third difference. What? del of del square y del of 12x plus 6. Now del of this 12 is 12 is 0, implies del q y. This is answer. Just differentiate it. Whenever given polynomial is in terms of simple polynomial, just convert it in factorial notation, and for finding difference, third order, fourth order, fifth order, just differentiation. Do the differentiation, then you can get it. Okay, so factorial notation, conversion in factorial notation can be done also in other way. That is, we know that what? If del of we can also find it. How? Suppose y equals to, here first coefficient of highest power of x are always unchanged. So just we can write 2x cube plus b x square plus c x plus d. Select. Then we know that 2x means what? X minus 1, x minus 2 plus b x minus 1 plus c x plus d. And left side is what? Y. Y means 2x cube minus 3x square plus 3x minus 10. Now, from both sides we can find the value of BCD. How? If x equals 0, then here x equals 0, then minus 10. Left side minus 10. Right side x equals to 0. So x equals to 0, this is 0, this is 0, this is 0, d. So d equals to what? Minus 10. Now, if x equals to 1, then just put x equals to 1 here. Then 2 minus 3 plus 3 cancel. 2 minus 10 minus 8, left side and right side. X equals to 1. X equals to 1, then this is 0, this is 0. X equals to 1, c plus d. C plus d. So from here, c equals to what? Minus 8 minus d minus 8 minus 10 equals to 10 minus 8, 2. So c equals to 2. Okay, c equals to 2. Now for b, if x equals to 2, then here 2 means just you can solve it. 2 means for 8 into 2 is 16. 16 minus 3 into 4, 12 plus 6 minus 10, left hand side, right hand side. X equals to 2. X equals to 2. 2 is 0. So now here 2 minus 1, 1 into 2 to 2b plus 2c plus d. Now from here just d equals to minus 10 and c equals to 2, just put here. So we can find 16 minus 12, 4 and 6, 10. 16 minus 12, 4, 6, 10, 10 minus 10, 0, 0 equals to here 2 into b, c equal to 2 to 4, d equals to minus 10. So here b equals to what? 2b equals to minus 6, b equals to 3, So b equals to 3. So BCD, here b equals to 3, b equals to what? 3, C equals to what? 2, 2, 3, 2 and D equals to minus 10. Minus 10. So this is 4 MB. You can write also by using this technique. Clear? Now, this is the factorial notation. In factorial notation, we can find difference by using differentiation. Because in factorial notation, del behaves like differential operator with factorial notation. So, since every polynomial can be written as a factorial notation of same degree, so just convert it, and for finding difference you can use differentiation in place of del. Okay, so this type of questions also may be asked in exam, so do practice for some questions. Okay, now factorial notation is completed. Now difference can be find function. Now there are two operators, shifting operator is there, okay, and relation between the operator. Just try to solve this type of questions. Okay, here relation between operator. Okay, there are two operators also. Now relation between operators del, backward del, center del, e and mu. There are 5 operators: forward operator, backward operator, central difference operator, shifting operator, average operator. Shifting operator is very, very important. Just like shifting operator, it increase. If we apply this operator on the function, that it increase by one time of increasing the arguments by one times of power 1 times of h. So fx plus h. That is e yx means what? Yx plus h. Argument is increased by one times of interval of difference. This is shifting operator. Just do one time more. E square yx means what? E yx. E yx plus h means what? One time more. Yx plus 2h. Similarly, eq yx means yx plus 3h. Therefore, n times, if we take n times yx, so yx plus nh. This is a shifting operator. Okay, so remember it. This shifting operator. And average operator, mu is average operator. Average operator is defined as just like this. Mu yx equals to average of yx plus half h, yx minus half h. Average of these two quantity. Clear? Average of these two quantity. Mu means average operator. Clear? Forward, backward, central del and shifting operator, average operator. These are the 5 operators, difference operator. Okay, so mu average operator is given by this. Clear? Now relation between these operators are very, very important, but here forward operator and shifting operator, they are fundamental. These are two fundamental operators. Every operators can be expressed in terms of this. Every relation between operators can be expressed in forward del and shifting operator. So these are the fundamental operators. For solving some questions, any questions, just you have to convert the relation in terms of forward and shifting operator. Then you can do further process. Okay, these are the fundamental operators. So what is the relation between these operators? Just relation between, just remember one by one, because very important these relation are also. Okay, here first is, see, first is forward del. Just write first all the relation, okay, one by one. Here we can write 1 del equals to e minus 1. Second is backward del 1 minus e inverse. Third, central del, I think, okay, central del equals to, these are the operators, remember it, not its value, itself has no value, these are the operator, just these operator are apply on function, clear? So this operator is equivalent to, this is equivalent to this, this is equal, these are the equivalent relation, this is equals to means this operator is equivalent to this operator, okay. So central del means e to the power half minus e to the power minus half, and fourth is mu, I think mu equals to, okay, half of the simple operator, okay, this is the operator. Now fifth is what? Forward operator can be written as E backward operator E and mu delta. E backward E, delta E half. These are all equal. Means in place of this you can use this, in place of this you can use this, in place of this you can use this, whatever we require. Okay. Sixth relation is E equals to e to the power h d, where d is equals to d by dx. Clear? So this relation can be found very simple by using definition. Okay, just one by one we can see how can we do it here. Since we know that forward operator was yx equals to forward operator yx equals to what? Yx plus h minus yx, we know it, and also we know by the definition of shifting operator, this means what? Eyx minus yx, here e minus 1 yx, we can write like this, del yx, because this is equal to this. So here therefore del is equivalent to e minus 1. All are equivalents, not equal, okay, equivalents. So first relation from definition. Backward relation also can be found. This first. Second is what? We know backward difference. From it, this is backward difference definition. So from here we can write yx minus e minus 1 yx minus 1 time h. So this can be written as 1 minus e inverse yx, here backward del yx, therefore backward del is equivalent to what? 1 minus e inverse, 1 minus e inverse, simple. This is from definition of central difference operator. Central difference definition, how can we write central difference definition. You know what? Third number, central difference of function yx. Okay, so central difference is what? Yx equals to central difference yx plus, sorry, what? Yx plus half h minus yx minus half h. So it can be written as e power half yx, e power minus half yx. So e power half minus e power minus half yx, central del yx. Therefore central del equals to e power half minus e power minus half. This is third part. Similarly, shifting average operator, you know, average operator. Average operator. Fourth part, what? Mu equals to mu yx equals to what? Half of yx plus half h plus yx minus half h. This is the average value definition. Just use e power half yx plus e power minus half yx. We can write like this now, e power half plus e power minus half yx outside. So we can write mu yx. Therefore mu equals to what? Half of e power half plus e power minus half. Okay, fourth is good. By definition, main thing is this two. Okay, and this is very very important property. E equal to e to the power hd. By using this, we can do many questions because derivatives is there, na? So here fifth can be proved very simple. Just solve it. This is equals to del, this is equals to del, this is equals to del. We can do it for this. So fifth, what? E backward del. So this is operator yx. Just we have to apply e backward del yx. Clear? This is equals to what? E backward del means what? Yx minus yx minus h. This is now e of yx, ex minus h. Just distribute it. E x plus h minus here e power 1. So one time add h. So y x minus h plus h. So we get yx plus h minus yx. So this is equals to what? This is equals to forward difference of yx. This is forward difference of yx. Or here e backward del yx. Therefore e backward del is equivalent to forward del. E backward del equal to forward del. Similarly, you can do del e, central del e power half. Just take it. This yx equals to and do. You can get forward. Just take it and do. Just like this. You can get forward. So this is the proof of up to this. Okay. Now proof of sixth. We know that here shift operator of fx, shift operator of yx, shift operator of yx means fx. We can write fx or yx also. So this is equals to what? Fx plus h. Now this fx plus h can be written by Taylor series. These are the relation between operators. Okay. Now last relation is here. Clear? By Taylor series we can write here fx plus f dash x h upon 1 factorial plus h square upon 2 factorial f double dash x this is by Taylor series by Taylor's series from calculus we know by Taylor series this can be written like this. Now this is equals to fx plus h upon 1 factorial derivative of fx plus h square upon 2 factorial double derivative of fx double dash. Similarly h cube upon 3 factorial dq fx just like this. Okay, we can write like this x cube upon 3 factorial f triple dash x and so on. Clear? Now here fx can be taken outside. So 1 plus hd upon 1 factorial h square d square upon 2 factorial hq dq upon 3 factorial and taken outside fx. Clear? And this is equals to, we know, exponential series e to the power hd in fx, not into operating implies e fx. Therefore e is equivalent to what? E to the power hd. E equals to e to the power hd. E equals to e to the power hd, where d is differential operator, derivative d. So this is important, very important. So these are the relation between operators. By using this relation we can solve many questions, just like a question here. Prove that del square by e to the power x okay, there is a question. Means these operators are very important. By using this operator we can solve some of the questions maybe asked in exam related to this, involving these operators. Okay, so remember it. Okay, by using these operators we can solve questions. Okay, so here solution. We have to show that e to the power x equals to del square by e, del square by e, e to the power x, e to the power x. E to the power x by del square e to the power x. Interval of differencing taking h. We have to show that this. Clear? We have to show that this. For doing this, we have to show that e to the power x equal to this. So right hand side take. So here we see that this is equals to del square upon e is equals to what? del square E inverse, just take it numerator, E inverse e to the power x. Okay. Now del square E inverse this by using shifting operator, e to the power x minus h. Clear? Here del square e to the power x into e to the power minus h. This is constant term, so can be taken outside. E to the power minus h del square e to the power x. Clear? So this is equals to this. So we get right hand side del square by e to the power x, e to the power x upon del square e to the power x is equals to, this is equals to this, put here minus h del square e to the power x into e to the power x upon del square e to the power x by using 1. Okay, just put. Now this and this are cancelled, so we get e to the power minus h constant term and e to the power e to the power x means e to the power x plus h by applying shifting property, e to the power x plus h, and this is equals to e to the power h minus h plus h, cancel e to the power x. This is left hand side. So proved. That means by using properties of operators, relation of operators or definition of operators, we can prove any type of relation which is given in terms of operators. Okay, so related to these operators, just solve some of the questions. Now take here questions for finding missing term. Very important questions for finding missing terms. Okay, so here just see how can we use the relation of these operators for finding missing terms of a given data. Okay, just like take question, given question. Okay, here find the missing term in the table. The value of x, y are given 2, 3, 4, 5, 6 value of x. So solution, missing term, there will be given a table where the values of x are at an equal intervals and values of y dependent variable are given also. There may be 1 or 2 or 3 values are missing. Then how can we find that missing terms? By using difference. Okay, so take these questions. Here solution. First of all, x should be at an equal interval. So here from this given table data, we have to prepare a table first of all. Okay, so value of x, we prepare the table, as, just see for preparing the table, right, values of x. Table is important. Okay, so we know preparation of table. First of all, write value of x, then value of y, then first difference of y, second difference. Here how many values are given? 4. This is the 4. 1, 2, 3, 4. 4 values are 4 entries are given. So difference of second difference and third difference is also y, and fourth difference also like this. Clear? This. Okay. Now write the values of x here. Just make the table very sincerely, because the table is very important for finite difference calculus. You have to find values. So 2, 3 up to 6. 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6. Okay. So this is our table preparation. 2, 3, 4, 5, 6. Given are 2, 3, 4, 5, 6. Values are given 45, 49.2, 45, 49.2, and another value is what? 54.1, 54.1, and this is missing value, and then 67.4, 67.4, and this is missing. Suppose missing value is a. Suppose missing value is, what is this? Y 0, y 1, y 2, y 3, y 4. These are the or notation for entries. Okay. Clear? This value is missing. That is y3. Okay. Now, table making is very simple. We know. How can we make table? Just difference, take difference. What? 49.2 minus 45 means 4.2 is there, na? This minus this, just right here, 4.2. Okay. Then 49.9, 54.1 minus 49.2. So 54.1 minus 49.2, 4.9. Okay, 4.9, and then y3 minus what? This minus this, y3. y3 minus 54.1, 54.1, 67.4, 67.4 minus y3. This is missing value, y3. We have to find. Okay. Now difference table creation is very simple. So just write the difference. Okay. So here this minus this right here. Okay, 67.4 minus y3. So in between difference. Now this minus this is here. So 4.9 minus 4.2 means 0.7. 0.7. Okay. And here this minus this means 0.59. Okay. And 10, 1, 5, 5, 4, 4. Y3 minus 59.0. 59. Okay. Now here this minus this just means this plus. So 1 5 1 to 1.5 1 to 1.5. So 1 to 1.5 minus y3 minus 2y3 is there, no? Minus 2y3. Well, this minus this means plus, minus 3 minus 3 to minus 2y3. Okay, now this minus this means minus y3 minus this minus this 59.7. 59.7 is difference. 59.7. Now 180.5. Now this minus this two total. So here 9 was 0, 1, 3, 3, 5, 8, 180, 180.5. 180.5 minus 3y3. Yes. 180.5. This minus this. Y80, 180.5 minus 3y3. Yes. Now this minus this is it here. Okay. So we get 240.2. This minus this. 240.2 minus 4y3. Minus 4y3. Minus 4y3. Yeah. Also, okay. This is the difference. Now, for finding the values of missing term, here is the missing term y3. Just we have to find y3. Here we are given a table. The values of x are 2, 3, 4, 5, 6, and entries. These are called entries y. 1, 2, 3, 4 values are given. So 4 values are given. That means just 2, 7, 5, 2, 1, 9, 0, 1, 8, 13, 14, 4, 1, 2, okay. Here, since we are given only 4 entries, just we know from the previous class, just if we are given n entries, then function can be approximated, that is y can be approximated by n minus 1 degree polynomial. That is, and we know that nth derivative of polynomial of, nth difference of a polynomial of nth degree is always constant. That is, higher differences are 0 here. So since here 1, 2, 3, 4 entries are given, so function can be approximated as a polynomial of degree 3. 4 are given, n are given, then n minus 1 degree polynomial can be approximated. So 4 entries are given, so function can be, yx can be approximated or represented by a polynomial of degree 3. 3 degree polynomial means third difference will be constant and fourth difference will be 0. Here fourth difference is this. This should be 0. That is, take this is equals to 0, then you can get the value of y3. Clear? Also third difference are constant. That means what? These two are constant. Constant is same way. Okay. So by taking this equal this, you can get the value of y3. Or you can take this is equal to 0, then you can get the value. Okay. So here, since only 4 entries are given, therefore fx or y or function, therefore function this y can be approximated or represented as third degree polynomial. So, fourth difference should be 0. That is, fourth difference y equals to 0. Fourth difference y equals to 0. Okay, for difference y equals to 0, y 0 we can treat as also y 0 we can write also, or for difference y 0. This implies 240.2 minus 4y3 equals to 0 implies y3 equals to 240.2 upon 4 equals to, just solve it, 60.05. 60.05. So this is answer, 60.05. Okay. This is the technique for finding missing value. Okay. Also, if number of entries are more than the 5, 6, 7 and there are 3, 4 missing terms, then you can get also the result by finding differences. Okay, by making difference table. Clear? Here, for finding differences, just you can use also the relation del equals to 1 minus e minus 1. We know this. So this is operator del equals to e minus 1. So here you can use also that thing, just like this. Since this, therefore del for y equals to 0. So we can write del means e minus 1 power 4 equals to 0. Clear? Is here this is y0, y0, just we can take also y0 is here, because if this is what leading down is this, so this is y0, so here e minus 1 power 4 means a minus b power 4, so by using minus 3 e cube a minus b power 4 plus 3 e square No. Here the coefficient, binomial coefficient is 4 minus 4 6 4. Okay. E power minus 1 power 4, e power 4 minus 4, e power 3 plus 6, e power 2 minus 4, e power 1 and plus 1. This of y. This of y0 equals to 0. This is clear. Plus 1 is there, na? Minus 4a. Now just apply this function e0, e power 4 e0 minus 4 e power 3 y0 plus 6 e power 2 y0 minus 4 e y0 plus y0 equals to 0. So here we know e power 4 y0 shifting property e4. So interval differencing is 1. Interval of differencing h equals to 1. So h here interval of differencing is 1. So here y0 means y4 minus 4y3 plus 6y2 minus 4y1 plus y0 equals to 0. Now putting all the values y0 1 2 3 4, y0 1 2 3 4 except y3, you can get also result. Clear? Just like this. Y4 67.4 minus 4y3, we have to find this. 54 plus 6 into y2, 54.1. 54.1 minus 4 y1, 49.2. 49.2. Okay. And plus 45 equals to 0. From here, just we see that 67.4 plus 6 into this, 6 into 54.1 minus 4 into 49.2 plus 45 equals to 4y3. So you can solve it and find 60.05. Just add, subtract and do it complete. Okay. So this minus what is go to here. So y3 equals to 60.05. 60.05. You can do it. So this relational equation also can be used for finding missing value. Okay. So for your attendance, just send me solution of 2-3 questions. Okay, just we are giving here one from for use relation between operators. Just use that all the relations, forward del equals to e minus 1 and so on. Okay, here questions are, we know relation between operators and relation can be used for solving questions. So do first question from there and second question is from missing term questions, and 2-3 questions also are there for involving relational questions. Okay, so note down and solve these questions and send me for your attendance. Okay, just use. Now always remember that for solving missing term, just how many entries are given. If n entries are given, then n minus 1 degree polynomial can be approximated. And then just create table, and suppose 3 entries are given, then just find third difference will be constant, fourth difference 0. So, and we can find missing terms. And also relational operator del equals to what? E minus 1. Backward del equals to what? 1 minus E inverse. and central del equals to e power half minus e power minus half, and average operator half of e plus half plus e power minus half. And also you know backward del, just if we get e backward del or backward del e, which both are equal to forward del, also del e to the power half. And main formula is what? E equals to e to the power hd. From here we can get a formula. What? This from here, log of e equals to hd. Clear? Log e equals to hd. So e to the power hd equal to this means hd equals to what? Taking log. So hd equals to log e. Here we see that hd equals to log e. E means what? 1 plus del. Here, from here we can write e equals to 1 plus del. So here we can write 1 plus del. So d equals to 1 by h log 1 plus del. And log a plus b formula we know. You can express it. So this relation is also very important. So it can be used also. Clear? So by using these operators and the technique, if n entries are given, then n minus 1 degree polynomial can be approximated. So n minus 1 difference, nth difference will be 0. So using that we can find missing term, and del is equals to, we can write e power something, third, fourth, fifth, third power fifth, and you can express it by binomial expansion. Then you can solve for y0, y1, y2, y3 and put the value and get the missing value. Clear? So solve these questions and send me for your attendance. Okay.